Hello everyone, my name is Saurabh Pant and let us continue with the Rank Booster series. In the last few videos I discussed about the first law of thermodynamics, and now let us carry on with the entropy part that comes with the second law of thermodynamics. Second law of thermodynamics simply says that universe keep on expanding, or entropy of the universe always increases, or entropy of an isolated system always increases. Now what is this term entropy? So देखो यार, if I go into depth of this, your previous concepts might get shattered, because a lot of people think entropy is the degree of randomness, or it is the randomness, it is the disorderness, or something like that. It is true that entropy is a measure of randomness. But exactly what is entropy? It has to do something with the heat to work conversion. I'll not go into the details of that. That is not relevant for us if we are preparing at this point of time. So भैया देखिए, entropy is a measure of randomness. That is enough for us. So if some system is more random, it will have more entropy. So the question which are very important for NEET and JEE examination, in fact recently last year 2019 NEET, the question has appeared in the examination of the same exact topic. So bhaiya, what we are going to discuss now is that in which case the entropy would increase or disorderness would increase, in which case the disorderness would decrease. So let's start from here. So SM naught order I am taking. What is this? SM naught molar standard entropy. Molar means for 1 mole. For 1 mole under standard condition. What is standard condition? 1 atm, and temperature is up to you. You can change the temperature also, but if nothing mentioned, I will take it to be 298 Kelvin. So the standard molar entropy, if we find, then gases will have much more standard molar entropy than liquid, than solid. Why? Gas particles, they are very randomly moving here and there. So more chaos, more randomness will be there, more disorderness will be there. On the other hand, when I check liquid, the disorderness will be lesser. On the other hand, if we have solid have very rigid structure, and very rigid structures, what happens? The disorderness or the randomness is very less. Next, if we compare CO, CO2, SO2, SO3, these are kind of questions which are not very readily available in the notes of many people or in the books. So easily you will not get. So how to compare? Keep one rule in mind. देखो भाई, think about it. In your room, one kid came, ठीक है ना भाई, and the kids, वो तो मतलब धमाल ही मचा देते हैं यार. So what will happen? When the kid will come in the room, he will distort the whole room. He will create a lot of chaos, a lot of confusion, a lot of disorderness in the room. If there are 2 kids, more disorderness. 3 kids, the home will become hell. So bhaiya, idea is very simple. Again, I have nothing wrong with the kids. I'm just saying it becomes messy. ठीक है भाई? Now, the more the kids, the more messy it becomes. A single kid can remain silent. 2 kids, manageable. 3 kids, out of control. We are 3 brothers and sisters. I know it very well. देखिए भाई, CO2, if I go, there are just 2 atoms here. There are 3 atoms here. So more atoms, more entropy. SO3, SO2, more atoms, more entropy. More atoms, more entropy. Acha, next, fluorine, chlorine, bromine, iodine. If I take all of them gases, acha dekho, if these 2 are gases, this is liquid, this is solid, then don't even think twice. Always the gases will have more entropy than liquid or solid. But if all of them are gases, then what to do? If all of them are gases, simple hai yaar. The bigger person will be able to move more randomly yaar. The bigger person will be moving more randomly. That means the entropy will keep on increasing with size. So we can say as the size increases, disorderness or the entropy or standard molar entropy increases. So this is a very important concept. Once I have compiled it for you from several books. So this will help you a lot. Now, entering into the questions here. Understand one more thing. 2 more things I'm writing here, not 1. 2 more things I'm writing here. If temperature increases, then also entropy increases. And if volume increases, then also entropy increases. So always remember this. In the case of expansion of ideal gas, if temperature is not changing, nothing else is changing, but volume change is given to you, you can tick ki more volume, more entropy. More temperature, if you heated up a substance, more temperature is there, then also more entropy is there. Now let us see. Iron solid, 100 Kelvin, 120 Kelvin. So temperature increased, so entropy increased. So delta S will be positive. Delta S positive means entropy increased, disorderness increased. Why? Very simple. Molecules were moving randomly. Temperature increased, they started moving more randomly because they got more energy. Next, NaCO3 on heating becomes Na2CO3 plus CO2 plus water. Here this is solid, solid, gas, gas. Whenever a reaction is given to you, always number 1, check solid, liquid, gas. Number 2, check the number of moles. We'll get to that. Now solid, solid, ignore, because in front of gases, solid entropy is negligible. So why you will consider the thing who is negligible? So bhaiya, solid became gas. So 2 solids were there, does not matter. Solid becomes gas, entropy 100% without any doubt will increase in the reaction. Delta S positive. H2 became 2H. देखो भाई, it was one gas molecule. This is 2 gaseous atoms. So number of gaseous particles increased. Here H2 is 1 particle. Here hydrogens are 2 particles. So they are separated. They can move more randomly. So again the entropy increased. Opposite of this question came in the NEET 2019 as well. Next, AgNO3 aqueous, NaCl aqueous. What will happen? They will react to form a precipitate of AgCl and NaNO3 aqueous. Think in this way. In this container full of water, you had AgNO3, that means Ag plus NO3 minus, they were moving randomly because it is aqueous solution. We write it AgNO3 together, we write the AgNO3 together, but in reality they are completely dissociated, 100% dissociated, completely dissociated, and they are moving randomly here and there. Also same is going on with the NaCl as well. But when these two react, they form AgCl, which is a precipitate, and this will settle down at the bottom here. So Ag plus was a free bird, Cl minus was a free bird, and then they got married, and bhaiya, independence is lost. So delta S negative. That means entropy decreased. Why the entropy decreased here? Because the freely moving birds finally settled down as a precipitate. So bhaiya, clear cut delta S will be negative, entropy will be decreasing. Graphite to diamond. Very brilliant question from here can be made. Dekhe, those who know about the structure of graphite have layered structure. So the layers can slide over each other. Diamond has a more rigid structure. Diamond is the hardest known natural substance, people say. So bhaiya yaar, it is very hard. Why? Because it is very rigid. So the disorderness is less here, and because the graphite can slide over each other, that is why people use graphite as lubricant in the engine oils also. You might have seen in the television ads as well. There also the carbon is used, graphite is used. So graphite, carbon, same, huh? Carbon has 2 allotropes, diamond, graphite, both are the allotropes. Buckminster Fullerene is also there, but both are allotrope of carbon only. So graphite has more randomness, more disorderness. Diamond has less randomness, less disorderness is there. So bhaiya, more entropy, less entropy. So when you go ahead, delta S is negative, entropy decreases. Here 2 more examples I will take. Just click to me, why don't we discuss the examples which in metallurgy also has come. For example, you have CO gas plus half O2 gas giving you CO2 gas here. So dekho bhai, this is a balanced chemical reaction, gas, gas, gas. So this kind of neglection you cannot do. You can't simply neglect solid like here in this case, because all 3 are gases. Now compare number of moles. So if number of moles also increases, then also entropy increases. Why? Because here entropy, I will not write Sm here now, I will write S0 here. So why not Sm? Because Sm is for molar entropy. If I increase the number of moles, S being extensive property, it depends upon number. If you don't know what is extensive intensive property, revise the notes, revise the theory, and then see this video. Yaar. This is rank booster video, not concept building video at this point of time. Concepts will be getting built automatically if you just revise what is extensive property. So S is extensive, more number of moles, more entropy. So here how many gaseous moles? So 1.5 moles of gas I can see here. Dekho, 1 here, half here, 1.5 mole. Product side, I have just 1 mole of gas. So bhai sahab, 1.5 moles of randomness was there, gas was there, it got concised and became just 1 mole. So as the number of moles will decrease, entropy would also decrease and delta S will become negative. Okay, bhai? I think very rapidly I am going, but the more time I save, the better it will be for your preparation. Okay, bhai? You can slow down the video in case you want, you can increase the speed of the video in case you want. That's the beauty of YouTube. You can handle as much the video speed as you are able to comprehend. In this case, what will happen? Dekhe, it is an open chain becoming a cyclic chain. That means a ring-like structure is getting formed. So if I'm the open chain, I can more randomly be moving, but when I become a closed chain, my hands get tied and the randomness decreases. So bhaiya, open chain to closed chain, randomness decrease, delta S becomes negative. Now here are two examples. There is the stretching of rubber band and boiling of egg, which are a little unconventional examples, not generally asked in the examination, but teachers teach this in the notes. So I will have to tell them, but these are not relevant for your examination as far as the NEET and JEE exams are concerned. But anyway, you can know in local exams it will come. Stretching of rubber band. Again, here the research is not yet completed. It's like proper research papers are not there by which I can say ki exactly this is the answer. But what people say is that on stretching of the rubber band, the polymers they align in a very proper direction and the randomness decrease. So delta S becomes negative. So my advice would be to just keep this in mind, ki stretching of rubber band, it looks like volume increase, entropy increase, but in reality, delta S is negative. I don't have a proper research paper, reliable research paper. I've seen some papers, but I was not very convinced with the matter written over there. Plus, also proper references were not given. So I would suggest you to just keep in mind for the local exams. Okay, bhai? Whenever you read further in the higher studies, if something new comes out, you can update your knowledge at any point of time. But at this point of time, anywhere you will see stretching of rubber band, either they will say no idea or they will say delta is negative. Works well. Boiling of egg, dekho, in boiling of egg, it looks like that liquid becomes solid. When you boil the egg, it becomes solid. So people think entropy decreased, whereas the delta S becomes positive. So one explanation is that on heating, what happens? The protein structure in the albumin, it gets broken up into small particles, and when bigger particle breaks into smaller particles, the number of particles actually are increasing and randomness will be increasing. So these two are the unconventional examples which might not come in the NEET examination, JEE examination. Remaining are extremely important, and this is all about the rank booster series for today. Thank you so much.